Good afternoon, gentlemen and ladies. My name is Amjad Isaa. PhD student, third year, University of Nantes. This paper was prepared under the supervision of Professor Frank Skoff. So today we are I'm going to talk about assessment of uncertainty in the evolution of Markov chain for maintenance of pavement degradation. We have three objectives in our paper. The first objective is to calculate the transition probability matrix in the first order Markov chain. The second one is to analyze the effect of time step on the transition probability matrix. And the third one is to apply the assessment of uncertainty on three different pavements. The database, we work on real database from F-star for pavement, and we have a database from 5 departments in the west of France, and we have about 12,256 sections distributed among the three types of pavements. The indicator that we are working on is the pavement condition rating, the pavement condition index, and we have 5 condition states: very good, good, fair, poor, and very poor. The assumptions that we use in our work, almost all the sections have the same traffic, the same climatic conditions, the same structure and design, and all sections with the same age have the similar characteristics. So the first object is the Markov property. In our work, we try to approve the use of first order Markov chain through 2 examples. The first example was to use the frequency probability. So as we know, the first order Markov chain has 2 major characteristics. The first one is that it is state independence, which means that the future condition depends on the present condition regardless the past condition. So through the frequency probability procedure, we try to approve that if we have, for example, it was very good, our sections were in very good condition in the past and staying good in the present and good in the future, we found that the probability is, for example, 59%. And we took that if the probability in the past was good and staying good in the future, we have a probability of about 60%. So as the difference between the 2 percentages is almost small, we can say that we have a Markov chain property. The second one example is through using the chi-square test. In chi-square test, we usually calculate the expected frequencies and the observed frequencies and make like a comparison between them through chi-square. Here we propose that we have alpha 5%, which means the confidence is 95%. And for example, we calculate the chi-square for first row of our transition probability matrix for the rigid pavement. And we found that the difference between the observed frequencies from the real database and the expected frequencies through calculation using Bayesian distribution was almost the same values with slight, and we found that the chi-square value for this row, for example, was 0.15. Knowing that the chi-square for our assumption should be less or equal 3.84, which means that no significant difference between the observed and expected data, and this means that our assumption is true and we have a Markov property. The second objective is to find the effect of the time step We work on 5 time steps: 2 years, 3 years, 4 years, 5 years, and 6 years. But here, actually, we presented 2 time steps: the 2 years and the 6 years, and we try to make comparison. From both figures, we can see that the probability of very good condition is decreasing with time, but and the trend of the very good condition is almost stable comparing with other condition states like good, fair, bad, and very bad. And here we show that to stay in the same condition is decreasing with time. Increasing of a scatter for the other condition states comes from the assessment of condition states and from the database. As we said before, that we consider all sections in the similar age have the same characteristics. So it is easier to assess the change in condition state when we have larger time steps comparing with lesser time steps. The third property is to consider the assessment of uncertainty. Here we have 3 types of measurements: the rigid, the semi-rigid, and the mixed. We work with 3 statistical parameters: the mean, the standard deviation, and the coefficient of variation. We found that the coefficient of variation, which is the ratio between the standard deviation and the mean, is almost constant for the rigid measurement, which means that we can use the coefficient of variation in our model. And for the standard deviation, the decreasing means that the uncertainty is decreasing with time. However, for the semi-rigid and the mixed measurement, the trend of the standard deviation was not constant, and for that we calculate the statistical interval, the uncertain statistical interval, through the confidence interval of using 95% confidence interval. And for the semi-rigid, for example, we found that we can use sigma with value of 0.0718 within the confidence interval for the semi-rigid. And for the mixed pavement, we found that within the statistical uncertainty interval, confidence interval, we can use sigma with constant value of 0.0823. And to illustrate the effect of the time step on uncertainty, we found that if we take the propagation of, for example, for the rigid pavement for 30 years, for 2 years time step and 6 years time step, considering the mean value, the lower boundary and the upper boundary, we found that the range of certainty is decreasing with increasing the time step. Finally, our conclusions that we use the first order Markov chain as a probabilistic approach for identifying pavement maintenance, and we try to verify using Markov property through the state transition sequences and chi-square test. The Markov chain was identified through the calculation the transition probability matrix for different time steps, and the model of uncertainty assessment was based on the previously mentioned time steps. In general, the probability of very good condition state of pavement section is decreasing with increasing time step, and for the sigma, the trend is stay in the confidence interval of statistical uncertainty for semi-rigid and mixed pavement. Thank you for your attention.